Dear all, good day to all of you out there. You all know that UGCNET examination is coming, and I would like to discuss the questions which come for the UGCNET paper 1. And your second paper, of course, you already know, but for paper 1 there are questions which come from a lot of topics. So I'll be discussing the questions which have come from the previous years on various topics. So please watch my videos. So all the questions that I have discussed in this slides have come from previous years questions. So even though you may be coming from or you know a little bit of mathematics, you may be encountering difficulties while doing the question. So we will discuss some tricks and formulas which are used in the questions. So let us discuss each of the questions one by one, and it will probably help you for the examination. So today we will be discussing on the topic speed and distance problem. So let us move directly to the slides. By the way, I am Hema Ramachandran. I'll be coming up with more and more videos on UGCNET paper 1. If you like this channel, please subscribe. Okay, let us now directly go to the next slide. So here the formula used to calculate the speed of a person or train or questions of that similar type is speed is equal to distance by time. That is the formula that is used for almost all of the questions on speed distance problems. So since speed is equal to distance by time, we can say distance is speed into time. So that is the formula that is used for most of the questions. Okay, now we will discuss the type of questions that are coming. Let us see the first one. So question 1, a motorboat covers a certain distance downstream in 5 hours but takes 6 hours to return upstream to the starting point. If the speed of the stream is 4 km per hour, then what is the speed of the boat in still water? This question has been asked for the last time examination, UGCNET 2024. The answers are given as 1, 2, 3, 4. So how to do this problem? So this is actually the question asked is about the speed of boat in still water. We cannot directly apply the above formula. Instead, we need to know some tricks or a formula that is used to calculate the speed of the boat. So if the boat is going downstream, then the distance d is equal to boat speed plus stream speed into time, because we already know the basic formula, distance d is equal to speed into time. So if the boat is going downstream, you have to use this formula, distance d is equal to boat speed plus stream speed into time. Similarly, if the boat is going upstream, then the distance d will be boat speed minus stream speed into time. So let us apply this formula here. It is already given that the stream speed is 4 km per hour and the downstream time is 5 hours. Upstream time is also given as 6 hours, and you have to calculate the speed of the boat. So let B be the boat speed. Then using the above formula, distance d is equal to boat speed plus stream speed into time for the downstream speed. We can say d is equal to b plus 4. 4 is the stream speed into 5 hours, because downstream time is given as 5 hours. Similarly, the next step will be formula for the upstream. The distance d will be equal to b minus 4, because it is going upstream. So b minus 4, b is the boat speed, minus 4 into 6, that is the upstream time. So now equate the two distances, because it is coming to the starting point, distances are the same. So equating the above, we can find that it's simple algebra. You can find out the boat speed is equal to 44 km per hour. So the answer is to the above question is option 3. So basic formula that you have to use for any type of problems that come like this will be downstream speed distance will be equal to board speed plus stream speed into time, and for the upstream we have to say distance d is board speed minus stream speed into time. So this question has been asked for the 2024 examination. The next question, that is, speed of a boat in still water is given as 5 km per hour and speed of the stream is 1 km per hour. A man rows a certain distance of 24 kilometers and comes back to the starting point. Find the total time taken by him. So this is a question similar to the above, again asked for the same examination, and here we have to find out the total time. Options are given 1, 2, 3, 4. So how to calculate this? We use the same formula that we have already discussed, that is, if the boat goes downstream, distance d is equal to boat speed plus stream speed into time, and boat goes upstream, boat speed is equal to distance d is boat speed minus stream speed into time. So here distance d is given as 24 kilometers and the boat speed is given as 5 km per hour. Stream speed is also given 1 km per hour. We need to calculate the time. So time, let it be small t. So in the first case 24 is equal to 5 plus 1, boat speed is 5 plus 1 into t. So from there we can calculate the time as 4 hours, and upstream the distance is given as 24 is equal to 5 minus 1 into t. From this t can be calculated as 6 hours. So the total time is the time for the downstream plus time for the upstream. So that is 4 plus 6, that is 10 hours. So the answer to this question is the option 2. So this is how we calculate for the questions similar to the above. Now let us discuss another type of a problem which also comes under speed distance problem. Here two trains A and B, 125 meters and 100 meters long, are moving in opposite directions on parallel tracks. The velocity of the train B is 3 times that of train A. The trains take 4 seconds to pass each other. Calculate the velocity of each train. So that is the speed is being asked for the above trains. So options are given here. So let us see how we can do this problem. So here it is given that the velocity of the train has to be found out. So for train A we have to find out the velocity, and for train B also we need to find out the velocity. So velocity of the train A, let it be small v, then velocity of train B is given as 3 times that of A, so 3 times v, and it is also given that they are moving in opposite directions. So opposite directions means you have to find out the relative velocity, that is the difference in velocities. Because they are moving in opposite directions, we have to take 3 times v, that is velocity of train B, as minus 3v, and when we subtract v minus of 3v, that becomes plus v plus 3v, that is 4v. That is the relative velocity, and using the speed distance time relationship, speed is equal to distance by time, 4v will be equal to the sum of the distances of the trains, 125 plus 100 divided by 4. So from that we get 16v is equal to 225, and from this velocity is equal to 14.1 meter per second. That is, the train A's velocity is v and train B is 3v. So 14.1 meter per second is that of train A, and 3 times that of 14.1 will be that of B, 42.3 meter per second. So the option will be answer 3. Next we will discuss another type of problem. See here, a car completes a journey in 4 hours. The first half at a speed of 40 km per hour and the second half at 60 km per hour. Find the total distance covered. So, here a car is moving at 2 different speeds and we have to find out the total distance covered, and the total journey is covered in 4 hours. So here options are given. Let us see how we can calculate. So in this type of problems we have to use a formula. Here if the certain distance is traveled or covered in x kilometer per hour and another distance in y kilometers per hour speeds, then we can calculate the average speed using this formula xy divided by x plus y. So in bottom please check that it is within brackets. X plus y you have to include in brackets. So here the speeds are given as 60 and 40. So you can say it is xy by x plus y. So 60 into 40 by 60 plus 40 is the average speed, that is 48 km per hour. So once you know the speed, we can calculate the distance. Distance is equal to speed into time. So 48 into 4, that is 192 kilometers. So the answer will be option 4. Now we will see the next type. Here you can see a student walks from his house at a speed of 34 km per hour and reaches the school 10 minutes later. If he walks at 4 km per hour, then he reaches the school 10 minutes earlier. What is the distance between the school and the house? You can see various options are given. So here the speed is given, and in the first case he has a speed of 3 km per hour, but he reaches home 10 minutes later. And if he walks at another speed, then he reaches the school 10 minutes earlier. So how to deal with this type of problems? You can see here the formula used, that is you have to calculate the difference between the timings. Okay, so if the timings in this type of problem, the timing is given as one is later and one is earlier. So if one is late and one is earlier, then you need to add the timings. Suppose you have a question in which the timings are both are late or both are early, then we need to subtract the timings. So let us say the distance is about x kilometers. The difference between the timings will be 10 plus 10, because here the boy has reached, one is earlier and another is late. So we need to add the two timings, so 20 minutes. So the answer should be in kilometers, distance in kilometers. So time is always in hours. So when you have the time in minutes, we need to convert it into hours. So 20 minutes by 60. 60 minutes is 1 hour is 60 minutes. Therefore 20 by 60. So that is 1 by 3 hours. Now using the difference in the speed distance. So x is the distance, x by 3 difference in timings, similar difference in the speeds, x by 3 minus x by 4 will be equal to 1 by 3, and from this we calculate the, using LCM you can calculate 4x minus 3x by 12 is equal to 1 by 3, and from that you can calculate x as equal to 4 kilometers. So distance travelled can be found out. So here in this type of problems we need to find out the difference in timings. If one is late and one is earlier, we need to add up the timings, and if both are late or both are early, then we need to subtract the timings. So the answer becomes option 3. Now let us see the next type of problem. You can see Mani starts from home at a speed of 30 km per hour and reaches the school 20 minutes late. Then he increases the speed by 15 km per hour but reaches late by 8 minutes. How far is his school from home? So here also similar type of problem, but here you can see there is something here, that the speed is increased by 15 km per hour. That means first time his speed was 30, it is increased by 15, means we have to add up 15 to 30. Okay, that is the next speed. So next speed will be 30 plus 15, which is 45 km per hour. But the way to answer this question is the same type. So first speed is 30 km per hour. Second speed, it is given that it is increased by 15 km per hour. So the speed will be 45 km per hour. Now difference between the timings, when we calculate here, it is both are late. So we are subtracting 20 minus 8, that is 12 minutes, and 12 we convert it into hours. So 12 by 60, that will be 1 by 5 hours. Now from the formula for distance is equal to speed into time. So d by 8 will be equal to, or d by s is equal to t. Similarly, for calculating the distance speed time relationship, distance by speed is equal to time. So different speeds are there, d by 30, and the next one speed is d by 45, will be 1 by 5. So from there, d by 90 is equal to 1 by 5, or d is equal to 18 kilometers. So that is the value for distance. This is the next type of a problem. Then you have another type of problem here. Arun covers a distance at a speed of 24 km per hour in 6 minutes. If he wants to cover the same distance in 8 minutes, what should be her speed on hour basis? So here you can see the same distances traversed in different timings. One is 6 minutes, one is 8 minutes, and you have to calculate on an hour basis. So it convert it into hour basis. So the distance is the same in both the cases is already specified. So speed 1 into time 1 will be speed 2 into time 2. So we need to calculate in hours. So we have to convert each and every time to our formula. So speed is 24 into 6 by 60 is the formula for converting minutes into time, into hours. So speed 2 into 8 by 60, that is conversion into hours. From this we calculate speed 2. Speed 2 will be 18 km per hour. So that is the answer is option 1. Then the next type will be, a man covers 60 kilometers in 4 hours. Find the speed in meter per second. So here you have a simple straightforward problem, but the question here is to find out the speed in meter per second. So even though the question asked is in hours, we need to convert it into meter per second. So the same formula holds here also. Speed is equal to distance by time. So 60 by 4 is 15 km per hour. But we need to convert this kilometer per hour to meter per second. So this is the conversion formula. That is to convert kilometer per hour to meter per second, multiply by 5 by 18. So once you have calculated the time, the speed in 15 km per hour, that is the speed, then we need to convert it into meter per second. So kilometer per hour to meter per second conversion is multiply by 5 by 18. So speed is 15 into 5 by 18, which will be 25 by 6. So answer will be option 3. So these are the different types of problems that usually come up for speed distance formulations, and most of these are the different variety of problems that have been already asked for the previous years. So I hope this is useful to all of you, and we will be discussing more and more topics on UGCNET paper 1 in the coming days. So please give your valid feedback and also subscribe my channel. Thank you.